Welcome back. In Chapter 8, we'll discuss hypothesis testing. Hypothesis testing represents a useful extension of confidence interval investigation. This is another method of inferential statistics used to test whether the data at hand supports a hypothesis or not. Some examples of hypotheses that need to be tested are: hyperactivity is unrelated to consuming coffee. Drinking more than 3 cups of coffee every day causes increased anxiety and irritability. Consuming too much sugar will cause weight gain trouble due to eating too much among adults. This chapter introduces the statistical study to investigate these claims. Let's define what a hypothesis is. A hypothesis is a premise or claim about a population parameter that we want to test or verify by using statistical techniques. Typical population parameters that we want to test are population mean, mu, population standard deviation, sigma, population proportion, p, etc. This slide shows more terms used in hypothesis testing. A null hypothesis, H0, represents the currently accepted value for a parameter. H0 comes from previous surveys or previous data sets. Alternative hypothesis, H8a, is also known as the research hypothesis. It involves the claims to be investigated that are in contradiction with the null hypothesis. Let's go through an example of defining the null and alternative hypotheses. It is believed that a candy machine makes chocolate bars that are on average 5 grams. A maintenance worker claims that the machine, after maintenance, no longer makes 5 grams bars. Define HO and HA. The solution is very simple. H0, null hypothesis, represents the currently accepted value for the parameter investigated. In this case, H0 states that mu is equal to 5 grams. HA is the alternative hypothesis, or the claim to be tested. In this case, HA states that mu is different from 5 grams. Let's have a look at an important remark. H0 and HA are mathematical opposites. This implies that if H0 is equal to a value, then HA must be different from that value. If H0 is greater than or equal to a value, then HA must be less than to that value. The combination of H0 and HA covers every possible scenario. After investigating the alternative hypothesis, 2 outcomes may happen. Either you reject the null hypothesis, H0, claiming the null hypothesis is no longer true, or you fail to reject the null hypothesis, H0. H0 is always the currently accepted hypothesis. Let's do another quick example on defining the null and alternative hypotheses. Doctors believe that the average teen sleeps on average no longer than 10 hours per day. A researcher believes that teens on average sleep longer. Pause this video for a few moments and write HO and HA. The following slide shows the answer. H0 states that mu less than or equal to 10 hours. HA states that mu greater than 10 hours. Having defined the null and alternative hypotheses, how to test a hypothesis? Recall that the null hypothesis, H0, and the alternative hypothesis, HA, are complementary to each other. Moreover, there exist 3 possibilities for H0 and HA, as shown in this table. The following table shows every null hypothesis with its corresponding alternative hypothesis. Notice that H0 uses 3 symbols containing the equal sign: equal to, less than or equal to, greater than or equal to, while H8 does not include the equal sign, not equal to, less than, greater than. It is important to notice that when the alternative hypothesis H8 state that the true population mean is more than the claimed value, it is a right-tailed test. When the alternative hypothesis H8 states that the true population mean is less than the claimed value, then it is a left-tailed test. And finally, when the problem statement states that the alternative hypothesis says that the claimed population mean is different from the claimed value, then it is a two-tailed test. It is important to take time to read and understand a given problem statement before developing an answer. This cheat sheet shows 6 easy steps to follow in order to conduct a hypothesis test for the population mean when the standard deviation of the population is known by using the critical value approach. Step 1. Read carefully the problem statement and develop a claim about the population mean. Step 2. Write the null and the alternative hypotheses. Step 3. Extract the statistics from the problem statement, like the hypothesized population mean, the sample size, the population's standard deviation, and the significance level. Don't forget to check the normality. Step 4. Calculate the test statistic with the given formula. Step 5. Find the critical value from the z-table or by using Microsoft's Excel and use it to reject the null hypothesis if the test statistic falls in the rejection region. Finally, Step 6, write a concluding statement. Pause the video for a few moments and have a look at this table that shows further details about Steps 2, 4, and 5 described previously in the cheat sheet. Now we are ready to solve problems about hypothesis testing. It was perceived that the mean age of college students completing their degree in the Boston area was 23. A random sample of 42 students was collected and had a mean age of 23.8. Suppose their ages are normally distributed with a population standard deviation of sigma equals 2.4. Can we infer at alpha equals 0.05 that the population age has changed? Pause the video and use the cheat sheet provided in the textbook to solve this problem. Let's look at the solution. Step 1. The claim is that the mean age of college students in the Boston area is 23. Step 2. Null hypothesis H0 states that mu is equal to 23. Alternative hypothesis H8 states that mu is not equal to 23. It is a two-tailed test. Step 3. Data. Collect the data needed to conduct the hypothesis test. Hypothesized population mean is 23. Sample mean is 23.8. Sample size is 42. Standard deviation is 2.4. Significance level alpha is equal to 0.05. Step 4. Test statistic. Calculate the test statistic z equals 2.16 and find the critical value using the z-table or Excel. Since the test statistic of 2.16 is more than the critical value of 1.96, there is enough evidence to reject H0. Therefore, we have enough evidence that the mean age of college students in the Boston area has changed. Let's work another problem. A math professor claims that it takes no more than 50 minutes to complete a 4-problem exam. A selection of 55 students was timed while undergoing the exam. The students obtained an average completion time of 51.5 minutes with a standard deviation of 7 minutes. Use a 1% significance level to investigate the professor's claim. Pause the video and use the 6 steps to find an answer. The solution to this inferential statistics problem is very straightforward by using the cheat sheet provided in the textbook. Step 1. Carefully read the problem statement and make the claim. In this case, it takes no more than 50 minutes to complete a 4-problem exam. Underline the word "no more than," which implies a right-tailed test. Step 2. Express the null and the alternative hypotheses as shown. Step 3. Get the statistics from the problem statement as shown. Step 4. Calculate the test statistic. Step 5. Get the critical value from the z-table or by using Microsoft's Excel and compare it with the test statistic. Since the test statistic of 1.589 is less than the critical value of 2.32, we fail to reject the null hypothesis. And finally, step 6, make a concluding statement. Something like, the sampled data does not allow us to reject the claim that it takes more than 50 minutes to complete a 4-problem exam. Let's have a look at another method, slightly different, to conduct a hypothesis test by using the p-value approach instead of the critical value. The probability that corresponds to the test statistic, referred to as the p-value, is compared to the specified significance level alpha of the hypothesis test. While the critical value method uses a critical value that belongs to the z-axis, the p-value method uses the probability, area under the bell curve, for the probability test. This is illustrated in Figure 8.1. Let's do a few exercises of finding p-values. Find the p-value for the following cases. 1. Claim mu is less than 26. Test statistic z equals negative 2.13. 2. Claim mu is greater than 74. Test statistic z equals 1.89. 3. Claim mu equals 1.55. Test statistic z equals 2.89. The following slide shows the step-by-step procedure to solve this question. Step 1. Use the claim to identify the test. If the claim includes the equal sign, like equals, less than or equal to, or more than or equal to, then it should be put in the null hypothesis. Otherwise, the claim should be put in the alternative hypothesis. Step 2. Use the test statistic to find the limits of the rejection region. Step 3. Use the z-table or Microsoft's Excel to find the p-value. So, in question 1, the p-value is 0.0166. Keep in mind that p-value stands for probability value, and it is the shaded area under the z-distribution graph. Follow the same step-by-step procedure as shown in the following slide for the right-tailed and the two-tailed tests. This cheat sheet shows an update of the hypothesis test that uses the p-value approach. Notice that Step 5 uses p-value instead of the critical value. Otherwise, the rest of the cheat sheet is the same as before. This table shows further details about Steps 2, 4, and 5 in the cheat sheet. Pause the video for a few moments and have a look at it. Let's work an example on hypothesis testing with p-value approach. Social scientists want to investigate the age of marriage and divorce rate. One researcher claims that the average divorced male was less than 25 years old. A survey of 40 divorced males shows their average age on the day of their wedding was 24.8, with a standard deviation of 2.7 years. Use the p-value method to test the researcher's claim. Use alpha equals 0.05. Pause the video and try it. The solution is straightforward with the step-by-step procedure proposed in the textbook. Pause the video and compare your results with the solution. For more lessons on descriptive and inferential statistics, check out our textbook, Illustrated Statistics for College Students, available on Amazon. Thanks for watching.